ఈరోజు ఇచ్చేస్తాను. Yes, guys. Hello, everyone. So, in the previous class, I was discussing about how different mountains were formed in different areas, guys. Okay. So, we spoke about North America. We spoke about South America. Okay. Can you open Africa map, everyone? Can you open Africa map? Now, in Africa map, in this particular part, can you all check Atlas Mountains? Can you check Atlas Mountains? In this particular part, can you check Drakensberg Mountains? Drakensberg Mountains. Yes. So, guys, just remember, one side you have Atlas Mountains, another side you have Drakensberg Mountains. They were formed when all the continents came together to form Pangaea. Okay. So once upon a time, it was active. As of now, it is not active. Okay. It is dormant. So continent collision occurred to form these type of mountains. So they are called as fold mountains. And in this particular part, can you look for Mount Kilimanjaro? Can you check Mount Kilimanjaro? Tanzania region, you will observe Mount Kilimanjaro. Yes, guys. See, guys, as you are aware, Africa is splitting into two. One side you have Sudan plate, another side you have Nubian plate. As Africa is diverging, you have got few volcanic islands like Mount Kilimanjaro. Okay, so I want you to write two things here. In Africa, one, Atlas Mountains, two, Drakensberg Mountains. Once in prelims, they asked, in which continent do you have Atlas Mountains? So Atlas Mountains, Drakensberg Mountains, both these are old fold mountains and they are formed during the formation of Pangaea. During the formation of Pangaea. This is very, very important for you. Then, guys, when we look at the third one, okay, what you will have is Mount Kilimanjaro. Mount Kilimanjaro is active volcano and basically it is near your divergent boundaries. Divergent boundary. Okay, this is about Africa. Then let us look at Australia. Australia. Now, when we look at Australia, guys, in this part of Australia, can you see Great Dividing Range? In this part of Australia, can you see Great Dividing Range? Yes. Guys, this is also old fold mountains. You can write Australia hyphen Great Dividing Range, old fold mountains, formed during Pangaea. Formed during Pangaea. Okay. Everyone, can you see in New Zealand? In New Zealand, can you check? You will have like Southern Alps. Southern Alps. Yes. Guys, that is Aniket, Atlas and all were formed when all the plates collided during the formation of Pangaea. At that time, they used it to give different plate names, so not required. Don't worry about it now. Southern Alps. Southern Alps. Okay. Now, this is formed because of Indo-Australian plate colliding with Pacific plate. All these are not so important, guys, but you should be aware about the names. That's it. Everyone, can you open Europe map? Southern Alps are Engfold mountains. Engfold mountains. Can you see Europe map, guys? Europe map. Guys, in this part, do you have Scandinavian countries or Scandinavian mountains? Guys, that is my old fold mountains. Europe, I will have Scandinavian. I hope you are writing along with me. Scandinavian mountains, which are also old fold mountains. Second, everyone, can you check Ural mountains? Can you check Ural mountains? Ural mountains. Guys, that is also old fold mountains. And as I tell you, whenever something is old fold mountains, they were formed during the formation of Pangaea. Yes, remember Pangaea means supercontinent. That means all the continents came together to form Pangaea. And during that time, we had Scandinavian mountains and Ural mountains. Next, guys. Next. Guys, in this part, France, you see, guys. France and Germany part, you see. France and Germany part, you see. You will have Rhine Rift Valley, plus one side you will have Vosges Mountains, and another side you will have Black Forest. Can you see? France and Germany, at least Black Forest will be there. France and Germany, physical map you see. Vosges and Black Forest. And this is a typical example of block mountains and rift valleys. Typical example of block mountains and rift valley. Okay. Now, can you see here, guys? Alps mountains. Can you all check Alps mountains? Yeah. Nikhil, even Black Forest is there, that's enough. Not all atlas give Vosges. Okay. Can you see Alps mountains? Yes, can you see in between Caspian Sea and Black Sea? Do you have Caucasus Mountains? Caucasus Mountains. See, you have Alps. You have Caucasus Mountains. These are Engfold mountains. These are Engfold mountains. Everyone done? Now, you see, in this part, this Asia map you open. Turkey you see. Alps and Caucasus mountains. Can you see Turkey, guys? In Turkey, which mountains can you check? Turkey region. Taurus. Good. Good. Iran region. Can you all check this? Iran. Elbrus and Zagros. Iran region. Can you check two mountains? Elbrus and Zagros. Guys, those who are not able to find, please note down. After this, see in internet and find out this. Okay? Then guys, Afghanistan and Pakistan region. Afghanistan and Pakistan region. Do you have Sulaiman, Hindu Kush, Hindu Kush, India, you will have Himalayas. Can you all check this? India, Himalayas. China, everyone, China. Can you see here? Kunlun Shan. Kunlun Shan. Guys, see here, everyone, in this region, Myanmar region, do you have Arakan Yoma, Peguyoma? Do you have Arakan Yoma, Peguyoma? Everyone? All these are Engfold mountains. All these are Engfold mountains. Please note this down quickly. Aniket, in Australia, Great Dividing Range. Did you see? Did you write these? Shall we move to the next? Guys, everyone, see here. In this part, Pacific Ocean, in this part, you will have Aleutian Islands, correct? It is formed because of North American plate converging with Pacific plate. Next, Kurile Islands plus Japan. Yes, they're all volcanic only. That's why it is Pacific Ring of Fire. Japan plus Taiwan. Kurile, Japan, Taiwan. Please understand, from above you will have North American plate. From beside you will have Eurasian plate. From beside you will have Pacific plate. And also you will have Philippines plate. So there are several plates which are converging in this particular part. Yes, Srirang. Please see, it is convergence between 4-5 plates. Converging between 4-5 plates. Everyone see here, this part is. Okay. If you consider this part, we call them as islands of Southeast Asia. Islands of Southeast Asia. Sushmit, please, Sushmit, these are islands. I'm writing, no, islands. Don't get confused. They're islands, volcanic islands. If they're inside the water, we call them islands, no? Islands of Southeast Asia. They're formed because Eurasian plate has converged with Indo-Australian plate. It has converged with Pacific plate and Philippines plate. See guys, for exam, you just need to remember mountains. That's it. No need to remember the plates. But remember, I want you people to have clarity about one aspect. Whenever earthquake occur in Japan, it is important for you to know which plates are converging near Japan. When earthquake is occurring near Taiwan, I know you people are not going to write exam this year. You will be writing in 2025. I don't know which area will have volcano. At that point of time, if you have clarity about the notes, that's good enough. Okay, this is only with respect to your understanding. Okay, because suddenly if there is some earthquake or something in any part of the world, they may ask us questions. That's why this is important for us. Is this done, guys? Is this done? Now, Kennedy, only when there is some sort of what you call as uh, current affairs, else no need to do it. Yes, Anjali. Yeah. Uh, Aditya, just check once. See here, in this region it comes. North American plate would be like this. Yeah, Sushmit. See, guys, what I'm trying to tell is based on current affairs, you should read. Okay. Write everything as of now, but based on current affairs, you should read them. Okay. Yeah. Yes. Sushmit, I'll be doing Iceland with respect to what we call as uh, mid-oceanic ridges. We have a topic of studying inside the earth. At that time, I'll give you this. Okay. Okay. Everyone, see, guys. Next, I want to teach you everyone. Geomorphic processes. Okay, geomorphic processes. Now, what exactly is geomorphic processes? We will have two types of processes. Guys, geomorphic basically means how exactly a mountain is formed, how exactly waterfalls is formed, how exactly lakes are formed, anything for that matter, how it is formed. That is called as geomorphic processes. In geomorphic processes, we try to study what we call as endogenetic or endogenic processes. We also have something called as exogenetic or exogenic processes. So we will have two things, guys: endogenetic and exogenetic. Okay, endogenetic basically means whichever is occurring inside the earth, guys. So if something is happening inside the earth, then it is called as endogenetic processes. If something is happening outside outside the earth, it is called as exogenetic processes. Endogenetic is due to convection current in the asthenosphere. Convection current in asthenosphere that is responsible for endogenetic. If I look at exogenetic, we normally say that it is purely due to, energy from sun, guys. Okay, energy from sun is responsible for exogenetic. I'll explain exogenetic and all, but just remember these processes. Now, endogenetic is basically divided into two processes. Okay, endogenetic is divided into two processes. See, guys, based on time period. Okay, one is known as slow processes. So some processes may occur slowly, some processes may occur fastly. So if it is slow, we call it as slow processes. If it is sudden, we call it as sudden processes. So what exactly do we have in slow processes? Slow processes, we call it as diastrophic processes. Diastrophic processes are slow processes. Okay, what is sudden processes? We call it as catastrophic processes. Guys, can you tell me, earthquakes, does it occur suddenly or does it take time, guys? Earthquakes suddenly. So example for catastrophic is earthquake. Example for catastrophic is volcano. They all come under sudden processes. Diastrophic. For example, you tell me, guys, mountain building, especially fold mountains. You tell me, will it take less time or more time? As it takes millions of years, we call it as slow processes. Okay, this diastrophic is divided into two ways. Diastrophic is divided into two. Okay, so guys, uh, whenever the land moves vertically, it is called as a pyrogenic movement. That is, whenever the land moves vertically, we call it as a pyrogenic movement. Whenever the land moves horizontally, we call it as orogenic movement. Everyone, please see here. If something moves horizontally, I'll explain. Okay, so convergent boundary means what? Two plates move horizontally. Divergent boundary means what? Two plates move vertically, right? Transform boundary, sorry, away from each other. So transform boundary means both move parallel to each other. See, convergent, divergent, transform. In any ways, we call them as what? Orogenic movement. Okay, orogenic movement is mostly horizontal. Okay, what is a pyrogenic? Let us say I have ocean. So yes, we have ocean. Okay, now my hand is ocean, right? My hand is ocean. Now whenever land goes down and ocean comes above, okay, you see, land was like this, it went down like this. Is this vertical movement, everyone? If it goes down, can I call it vertical movement? Yes. If it comes up, can I call vertical movement? Yes. See guys, when it moves down, vertical movement, when it comes up, vertical movement. So you tell me, whenever it goes down, can I say water will come and cover this region? Yes, Sushmit, correct. Can I say water will come and connect? So can I call that particular thing as submergence? Can we call it as submergence, guys? Yes, yes. You tell me, if this part which has gone down, if it comes up, can I call it as emergence? Emergence. You might have heard Dwaraka has gone into the water, correct? Have you heard Dwaraka has gone into the water? Even today, Modi recently went there to do some puja and all. Yes. So that is called as submergence. Okay. But now it has come out. Some part of it has come out. If it has come out, we call it as emergence. Okay. You see, guys, slow processes are divided into vertical movement, horizontal movement. Vertical movement is called as epirogenic movement. Horizontal movement is called as orogenic movement. Now, whenever you have vertical movement, you will have submergence also, you will have emergence also. Orogenic basically means what? Horizontal movement. Due to horizontal movement, there is possibility of folds and there is possibility of faults. Okay, there is possibility of folds and there is possibility of faults. Do you get this, guys? Do you get this? Yes. Everyone? Everyone, you see now? Exogenetic means whatever is happening outside the earth. So when something is happening outside the earth, what exactly is happening? There will be weathering. There will be weathering. There will be mass movement. There will be weathering, there will be mass movement, and there will be erosion. So you'll have three processes, guys. Weathering, mass movement, erosion. These three occur simultaneously. Yes, Sushmit, everything is caused due to convection current only. Endogenetic movements are mostly because of that only. But you may say, sir, can I say glaciers are melting and it is covering the land, right? When water level increases, that doesn't come under epirogenic. Okay, that doesn't come under epirogenic. Done, guys. Done with this. Everyone wrote this. Yes. Yes. Now, guys, Anjali, leave Anjali. Don't worry about it. Aditya, no. Epirogenic is different. Orogenic is different. Don't get confused. Epirogenic is different. Orogenic is different. Hayat, yes. Next, guys, everyone. Let us talk about folds, guys. Folds. Okay. See, guys, whenever there is equal pressure on both the sides, then it is called as symmetrical fold. Equal pressure on both sides. It is called symmetrical fold. One side more pressure, another side less pressure, you will have asymmetrical fold. One side more pressure, another side less pressure. Then guys, let us imagine that the pressure is in such a way that one limb is stressed over another. Can you see? Here one limb is falling on the other. This part is called as limb, guys. One limb is falling on the other. Then it is called as overturned fold, guys. Overturned fold. When one limb is stressed on another. When one limb is stressed on another, it is called overturned fold. Symmetrical, both sides have same. Asymmetrical, one side is more, another side is less. Overturned, one is present above the other. Guys, remember, if this continues, sometimes one will fall over the other. One will fall over the other. This is called recumbent fold. When one limb is present on the ground, then it is called as what? Recumbent fold. But what happens, guys, if this is further compressed? If this is further compressed, one part of the limb will be broken and it will fall far apart. That is called nape. You see, when one is compressed in such a way that it will break down, that is called nape. When one limb is broken, then it is called as nape. Because sometimes within the rock or within anticline, you will have anticline and syncline. Can you see here? This is my anticline, this is my syncline. Within anticline, I have anticline and syncline. With its syncline, I have anticline and syncline. Now, this is called as anticlinorium. Anticlinorium. This is called as synclinorium. What is anticlinorium? Within anticline, we observe anticline and syncline. Here, within syncline, we observe anticline and syncline. Guys, 15 marks mains question they will ask you. Write about endogenetic and exogenetic processes. You have to write all this. Yeah, Abhishek, what will happen? The nappe, when you have compressed like this, you see, when you have compressed like this, one will break and it will fall away. Like, so it can go to anywhere. Yes, Anjali. Okay. Guys, you see, I'll write here only. When two limbs are parallel to each other, guys. When two limbs are parallel to each other, we will call it as isoclinal. Aniket, last one is within anticline and syncline. Sometimes what is going to happen? Because of excessive folding, they may further get divided into anticline and syncline. Both limbs are parallel. Done, everyone? Next, guys. Faults. Okay. Fault basically means movement in geography. As I told you, it is movement in geography. First, guys, please see this. If I have two blocks, if one block goes down due to divergent boundary, okay, if one block goes down due to divergent boundary, if one block goes down due to gravity, then it is normal fault. Then it is normal fault. See guys, normally near divergent boundary, we get normal fault. What is normal fault? It should go down due to gravity. Then you get normal fault. But sometimes you see, due to convergent boundaries, if it goes above this is called reverse fault. Yes, Kamalpal. First one is like Rift Valley itself. Bottom lava will come and it will try to take. Aditya, think about Rift Valley, how it goes down. Due to convergent boundary, if one block goes up due to gravity, then it is reverse fault. Himalayas is considered to be reverse fault. Some people say Himalayas to be reverse fault. Guys, in transform boundary, we normally observe that no, ma'am, sorry. Thank you. Goes up due to pressure, not gravity. Yes, Aniket. Sorry for that. Near transform boundary, when plates move parallel to each other, there will be fault. If they turn towards right, it is called dextral, and if they turn towards left, it is called sinistral. Normal fault example is Rift Valley. Example, fold mountains. Everyone done with this? Yeah. So what is right? See, I have like this. If it goes to the right, it is dextral. If it goes to the left, it is sinistral. But right and left is always with respect to where you see. There is no specific examples, guys. We can call St. Andreas fault. That is the problem, Kennedy. We cannot say which one is right, which one is left. It depends upon from where you see. Any fold mountains, Kavita, doesn't matter. Done? Aniket, today what happened to you? Okay, you see, you have like this. Okay, now if it moves like this, it is right. If it moves like this, it is left. Transform boundary move parallel to each other. Okay, done? Shall I move? Guys, now we'll try to see rocks. Guys. Okay, rocks. See, guys, initially, entire earth was in the form of molten magma. Okay, initially, entire earth was in the form of molten magma. So slowly what happened? The magma started cooling. Once the magma started cooling, it became hard, or we say it crystallized. Okay, that led to formation of one layer of the earth into solid. This part is called as lithosphere. Litho means rock, so we call rock sphere. Now these rocks, when we see, are broadly divided into three types. These rocks are broadly divided into three types. What are the three types? We call igneous rock, sedimentary rock, third you will have metamorphic rock. Igneous rock, sedimentary rock, metamorphic rock. Okay, guys. So now let us take the first type of rock, that is igneous rock. Now I told you that initially entire earth was molten magma, and the cooling of that led to formation of earth solid earth. Okay, so due to initial cooling of magma, due to initial cooling of magma, rocks were formed. Due to initial cooling of magma, rocks were formed. Such rocks are called as igneous rocks. Okay, the term igneous basically means fire. The term igneous basically means fire. Okay, so from fire, the rocks that have been formed is called as igneous rocks. Okay, cooling of magma led to rocks, and the rocks which are formed due to fire, that is fire here is hot. Okay, it is called as igneous rocks. Don't think fire created rocks. Okay, the magma which was hot, it looks like fireball, and from that what we got is igneous rocks. And here I want you to know, as first rocks were formed. Everyone think and tell. As first rocks were formed due to cooling of magma, as cooling of magma led to the first rocks, they are basically called as primary rocks. As the first rocks were formed due to cooling of magma, they are called as primary rocks. First point is what? You should be aware about it. What is the first point? First point is cooling of magma has led to formation of igneous rocks. Second, what are you seeing here? Second, what are you seeing here? As these rocks were first formed, we call them as primary rocks. Okay, we call them as primary rocks. Then everyone, you see here, third, what you should be aware is, it doesn't have fossils. It doesn't have fossils. That means coal, oil, natural gas will not be there in igneous rocks. Why? If you ask, you see, whenever from volcano lava flows, okay, whenever from volcano lava comes out, that lava is very, very hot. And if it touches any living organism, the living organism will become ash. Okay, if it touches any living organism, the living organism will become ash. As the living organism will become ash, we normally try to avoid, okay, or living organisms will not form fossil fuels in igneous rocks. I repeat this case. You see, if I have a tree, okay, the tree will fall. On the tree, sedimentary deposits will fall. It will become coal. If animal will die, on the animal, sedimentary deposits will fall and it will form oil and natural gas. Okay. So for coal or oil and natural gas, it should decompose. It should not burn. Okay. But here, burning occurs. Lava, when it touches any living organism, burning takes place. As burning takes place, igneous rocks will not have fossils. Remember this. Okay. Igneous rocks will not have fossils. Next, based on the location, based on the location where it is formed, where it is formed, it is divided into two things: intrusive igneous rocks, extrusive igneous rocks. Intrusive igneous rocks, extrusive igneous rocks. Okay. Now guys, based on the location where it is formed, we are dividing them into intrusive igneous rocks and extrusive igneous rocks, guys. Okay. Then everyone see here. Shall I move to next one? You see, I have Earth surface. In the Earth surface, there is a small opening. Okay. Lava is coming like this. Lava will flow into this. There is a small gap, guys. To that gap, lava flows. And some lava will come out. And that lava will flows out like this. Fine. Now you see, the lava which is cooling inside the earth is called as intrusive igneous rock. The one which is cooling outside will be called as extrusive igneous rock. Everyone? One is doing inside, it is called intrusive. The one which is cooling outside is called extrusive. Now, when I say intrusive igneous rock, example for this is granite. Intrusive igneous rock, example is granite. Please understand granite. Extrusive igneous rock, example is basalt. Basalt. Okay. Guys, I want you people to know one thing. Okay. Can you tell where temperature is more, where temperature is less, guys? Inside the earth, temperature is more. Outside the earth, temperature is more. Guys. Where temperature is more? Inside. Okay. Can I say, if temperature is more, cooling takes time? Can I say if temperature is more, cooling takes time? Yes. Outside, can I say cooling will take less time? Yes. You see, guys, as cooling takes time, the rocks will have, the rocks will have large granules. Large granules. I'll tell what is granules, guys. If you take a rock, within that rock, you will have different sized objects. That is called as granules. Okay, granules. But here you see, as cooling takes less time, the rocks will have fine grain. Guys, remember, fine grain means like chalk powder, guys. Okay, fine grain means like chalk powder. So, extrusive igneous rocks will have fine grain. Intrusive igneous rocks will have coarse grain, we call coarse grain. Okay, so one is inside, another one is outside. Inside is called as granitic, outside is called as basaltic. Is this clear, guys, everyone? Shall we move? Yes. In igneous rocks, we don't observe layers like sedimentary rocks. Remember, guys, in sedimentary rocks you will have different layers, but in igneous rocks you will not observe different layers, guys. Sedimentary, you tell me, layer after layer sediments keep accumulating, will it look like layers are formed? Okay, done with this, guys. Done with this. Did you draw, write this? Now, guys, now based on the shape of igneous rock, it is divided into six. Now, let us assume that you have one layer of earth, guys. Here you have another layer of earth, another layer of sediments, guys. Okay, so now when the lava flows, guys, the lava will try to accumulate parallel to the rocks. Can you see? Here the lava is accumulating parallel to the rocks. So whenever the lava accumulates parallel, it is called as sill or it is called as sheet. When magma, inside the earth is magma, outside the earth is lava, as it is occurring inside the earth, when magma accumulates parallel to bedding plane. When magma accumulates parallel to bedding plane, it is called sill or sheet. Bedding plane basically means we are talking about layers of rocks. Kennedy, but not the way sedimentary rocks form. You see guys, later you may have bedding planes like this. And then the magma which rises they may get accumulated perpendicularly. Okay, so when something is perpendicular to the bedding plane, it is called dike. When magma solidifies perpendicular to bedding plane. Guys, this was asked for 10 marks, guys, 2 years back. We call it as dike. Okay, see guys, sometimes you may have the deposit in this manner. When you look at it, when the magma solidifies in this region, it looks like mushroom shapes. No, mushroom shape. If the solidification occurs in the form of mushroom shape, then it is called as laccolith. Lith means rock. Okay. Lacco, not lacca. Laccolith. Done, everyone? Shall I move to the next one? Shall I? See, sometimes the deposits may occur in such a way that the accumulation may look like teacup saucer, guys. Okay. The lava accumulation may look like teacup saucer. So, if it is like saucer shape, then it is called as lopolith. If it is saucer shape, you call it as lopolith, guys. Sometimes, guys, you will have rocks, but deep inside the earth, you may have some steep sloped things called batholith. Batholith basically means formed deep inside with steep slopes. See, as concepts in geomorphology is done. Now it's just diagrams and names. That's it. In at home when you're practicing, you just need to remember the terminologies. See, guys, when something is in the form of anticline and syncline, so let us say you have two layers of anticline and syncline, and within this layer, if you have Magma accumulating in the form of waves. The sinus one will be called as phacholiths. Fine. Shall I move? Next, guys. The second type we have is sedimentary rocks. There's just one point I want you to write with respect to this. Igneous rocks are formed due to heating. It may be formed due to heating, cooling, and crystallization. Guys, you tell me now, uh, near convergent boundaries where there is destruction, subduction zone, will the crust melt in that particular part? Will the crust melt in that particular part? Yes. That molten one, will it rise? That molten one, will it rise? And will it solidify? Will it solidify? So there will be heating, there will be cooling, and there will be crystallization. Three things will occur. Guys. Okay. Now we need to have sedimentary rocks. Guys. So, okay. I'll start after break. Guys. Ma'am, Ring of Fire, Mid-Atlantic ridges, Indian Ocean, I will be doing along with volcanoes. Okay, volcanoes. We also have what we call as uh, ocean bottoms. There also we'll try to do. Okay. See guys, sedimentary rocks. The word sedimentary itself is derived from sedimentum. That means settling down. Settling down. Now, what exactly is happening in the process? I want you to understand this. You may have a water body, guys. Now, from here, a river will go. A river will flow. Guys, can you tell the mountain, will it be weathered, guys? Will it be broken down? The mountain, will it be broken down? So there will be breakdown called as weathering. Now you tell when the river is flowing, will the river carry the sediments, guys? Will the river carry the sediments? So can I say there is transportation of sediments? Yes. Okay. Then can I say all these sediments would be deposited in the lake or some water body? Now you tell when they deposit, will they deposit in layers, guys? Will they deposit in layers? Will the rocks also, you see? Can I say there will be deposition? The deposition is basically called as sedimentation. Now my point is, guys, you see, let us take the water body itself and let us assume that there is deposition. Okay, one layer of deposition occurred. There is another layer of deposition on top of this. There is another layer of deposition on top of this. Okay, let me say in between there was some water in between. Okay, in between there were some water. So you tell me, because of high pressure, can I say one layer of rock is putting pressure on the other layer, guys? One layer of rock is putting pressure on the other layer. Yes. Huh. So if you have one layer of rock putting pressure on the other layer, can I say the water whichever is there between these, will it go out? Will it go out? Yes or no? Because of the pressure. So that process is called as compaction. That process is called as compaction. What is compaction? When layers above are putting pressure on the rocks. That is called as compaction. Now my point is, you tell me, if you have different layers of rocks, now the salts that are present in this, okay, the salts that are present in this, can they join these rocks, guys? Can they join these rocks? The salt acts like a glue and they will join the rocks. That is called as cementation. That is called as cementation. See guys, you will have weathering, you will have transportation, you will have sedimentation, you will have compaction, you will have cementation. So the 5 processes, what are the 5 processes? Weathering. After weathering, you will have transportation. After transportation, you will have sedimentation. After sedimentation, you will have compaction. After compaction, you will have cementation. Guys, you tell me, will all this occur near the Earth's surface or will it occur deep inside the Earth's surface? Does all this occur near the Earth's surface or deep inside the Earth's surface? Near the Earth's surface. As they occur near the Earth's surface, 90% of 90% of sedimentary rocks are present near the Earth's surface. Ma'am, compaction means pressing, ma'am. Pressure. Pressure of above layers below. Yes. Yes, Aniket. Done, guys? You right? You write below. Due to exogenetic processes, rocks are broken down into smaller particles into smaller particles. These particles are carried by water and wind and is deposited into the oceans or lakes or rivers. Anywhere, guys, anywhere it may be deposited. The rocks formed in the sorry the sediments deposited in the water bodies accumulate in layers. Above layers would put pressure on layers below, which leads to compaction. Due to compaction, water accumulated between the layers are removed. Next, salt crystals present in water would act as glue and cement the layers, known as cementation. Rocks formed through this process is called clastic sedimentary rocks. Guess you tell me now. You see, sand will accumulate to form sandstone. Okay, mud accumulates to form mudstone. Okay, if different size accumulates, it will be called conglomerate. Okay, sandstone, mudstone, conglomerate, these are the different names that you give. Yes. Yes, Aditya. Yes, Aditya. Done with this? Okay. See, guys, we also have second type called as chemically precipitated sedimentary rocks, guys. Okay. Chemically precipitated sedimentary rocks. Conglomerate means mixture of different sized particles. You see, guys, you see, can I say ocean will have salt water? Ocean will have salt water. Okay. After evaporation, can I say salts are left behind? After evaporation, can we say salts are left behind? These salts, can I say, would accumulate to form, like, rocks. They are known as chemically precipitated sedimentary rocks. Okay. They are known as chemically precipitated sedimentary rock. What is the meaning of this? When you have salt water, when water gets evaporated, the salt crystals are left behind, and these salt crystals may actually accumulate to form rock. That is called as chemically precipitated sedimentary rocks. Okay, please write. Whenever ocean water evaporates, salt crystals are left behind. These may solidify over a period of time to form rocks. Example, yes, can I say lime may accumulate to form limestone? Similarly, you will have dolomite, you will have chert, you will have evaporite. Evaporite. There are different types of rocks which are formed due to chemical precipitation. Chemical precipitation, you have different types of rocks. Okay, then organic sedimentary rocks. Guys, you tell me, in sedimentary rocks, is there possibility of coal, natural gas and all? See guys, normally what happens when you have like this, when some fish and all will fall down, okay, on that there can be sedimentary deposits that will form oil and gas and coal. Okay, so some rocks will have fossils known as organic sedimentary rocks. Example, coal. Marble is metamorphic, Aditya. Organic basically means, ma'am, in that there must be some living organism present, which would form oil and natural gas or coal. Done. Oil and natural gas will be in liquid form, no ma'am, not in the form of rock. So we just write coal. Done, guys. Shall I move to the next? Okay. Are you understanding these, guys? Are you understanding these rocks? Are you getting comfortable with the terminologies? Yes. Did you understand endogenetic also? Did you understand endogenetic? See, guys, the difficult part of geomorphology or climatology or geography itself is done. Now it is just about the way you look other aspects. Okay. Next, you see, guys, what do we have? Metamorphic rocks. Metamorphic rocks. See, guys, metamorphic basically means change in forms. Change in form. That means one rock will get changed into another rock. Let me give you examples. Guys, let us take egg. If we heat it in water, will it become boiled egg? Yes. Yes. Now you see, those who don't know, like, just remember that if you put egg into hot water and if you keep on boiling, it will become boiled egg. Egg will be liquid, boiled egg will be solid. Chemical composition of egg is different, boiled egg is different. Okay. Similarly, let me say, I'll take milk. Okay, I'll take milk. If I heat it, if I heat it, and can I say from the milk itself, I'll get different products? From milk itself, I'll get different products. I'll get curd, I'll get ghee, right? So can I say milk might have undergone certain changes to form these, guys? Yeah, paneer. The change of form from one to another is called as metamorphic. Okay. Now, my question to you is, can you tell me when magma solidifies, can you tell what we are going to get, guys? Do we get igneous rock? Do we get igneous rock? Yes. Everyone, now you see here. Now you see here. Okay. Now, through this volcano is coming up, guys. Okay. Through this volcano is coming up. Lava is coming up, not volcano, sorry. Lava is coming out. Okay. Guys, can you tell me, because of lava, the rocks which will touch the lava, will it also melt, guys? The rocks which will touch, will it melt? Yes, guys. Will it melt and again will it form rock? Will it melt and again will it form rock? Yes. So here there is change of form. This is called as contact metamorphism. This is called as contact metamorphism. Okay. And here the change of form is due to heat, guys. Is due to heat. Okay. Second, you tell me now, if there is convergence between, two mountains, two crust, you tell me near the convergent boundary, due to pressure, can I say heat will be generated? Due to pressure, heat will be generated. And there also is there possibility of change of form. There also is there possibility of change of form. Yes. Due to pressure, if there is change of form, we call it dynamic metamorphism. Dynamic metamorphism. Now, what is metamorphism? Existing rock will become another rock. Did you all understand this, guys? Existing rock is becoming another rock. That is called as metamorphic. Now, what is the example, guys? If I take shale rock, okay, if I heat shale rock, it will become schist. Okay. If I take limestone, if I metamorphize limestone, I'll get marble. Okay. If we take quartzite, if we metamorphize, it may form slate. So like this, different rocks will change to different rocks. Okay, guys? Because of two things. One is heat, another one is pressure. Another one is pressure. This is called as metamorphic rocks. Yes, yes, ma'am. Don't worry about how it is changing. Done, guys? Done? Shall we move? See guys, metamorphic rocks may be divided into foliated. Foliated basically means layers will be there. This you will have layers in the rocks. Non-foliated basically means you no layers. Marble, quartzite are all examples of non-foliated. Everyone see here, I'll give you two things. Okay, first let us talk about igneous rock, guys. Okay, they're also called as volcanic rocks. Can you tell me why? They're also called as volcanic rocks. Can you tell me why? Can I say they are formed due to solidification of lava? Yes. And they are also called as primary rocks. Can you tell why? Because they were formed first. So, magma or lava, when they solidify, they are going to become your igneous rock. Yes. Second one is sedimentary rock. Okay, for this igneous rock, you need three things: heating, cooling, and crystallization. Heating, cooling, and crystallization. These three things we are going to do from igneous rocks, or these three things lead to igneous rocks. Then comes your sedimentary rocks. These rocks are formed due to weathering, transportation, deposition, compaction, and cementation. Then you will have metamorphic rocks. Lithification means formation of rocks. No, Aditi. They are primary because they were the first rocks to be formed. Metamorphic is due to heat or pressure. Guys, now you tell me. Let me say this is continental crust. This is oceanic crust, guys. Okay. Guys, you tell me, is this subduction zone? Is this subduction zone? Will it melt here? Will it melt here? Yes. Will the lava rise? Can it come out as a volcano? Will it form rock? Can you tell which type of rock it is? Igneous rock. Yes. Okay. Can you people tell me, think and tell, what is this rock, guys? What is the possibility of this rock? Can I say this rock can be igneous rock? Can I say this rock can be igneous rock? Can I say this rock can be sedimentary rock? Can I say this rock can be metamorphic rock? Yeah. Can I say here I may have igneous rock, I may have sedimentary rock, I may have metamorphic rock, and can I say these three are, can I say these three are melted here, and that is coming out and becoming igneous rock? So can I say igneous rock can be formed from igneous, sedimentary, and metamorphic? Can I say igneous rock can be formed from igneous, sedimentary, and metamorphic? Yes. Second, you people tell me now. You people tell me now. I have a mountain. I have a mountain. And can I say the mountain is eroded by a river, guys? Okay. Now my question to you is, if the mountain is volcanic, if the mountain is volcanic, then can I tell it may be igneous? It may be igneous. If the mountain is fold, can I say it may be sedimentary? Can I say these mountains, due to pressure, it might have become metamorphic? It might have become metamorphic. Okay, so guys, the mountain can be igneous mountain, the mountain can be sedimentary mountain, the mountain can be metamorphic mountain. Now you tell, when the mountain is eroded by the river and if it is deposited, can I say it will form sedimentary rock? Can I say it will form sedimentary rock? Now you tell me, can I say any volcanic mountain, any fold mountain, any igneous mountain, sedimentary mountain, metamorphic mountain, can it become sedimentary rock? Yes. So you tell me here, can I say igneous, sedimentary, metamorphic became igneous? Okay. Igneous, sedimentary, metamorphic is becoming sedimentary. Okay. Now you tell everyone. Think and tell this. Pooja, you see, ma'am, if the sediments are deposited in the ocean, will it accumulate to form sedimentary rock? Now everyone see here, when the magma rises, will this part change its form? Will this part change its form? Yeah. This rock can be igneous, can be sedimentary. This can also be metamorphic. So guys, can I say any rock will form any other rock? Any rock will form any other rock, guys? This is called as rock cycle. What is this? Rock cycle. You will have igneous rock. The igneous rock may become sedimentary rock. The sedimentary rock will become metamorphic rock. So sedimentary would become igneous. Igneous would become metamorphic also. Can I say each type of rock is becoming other type of rocks? But for this, heating, cooling, and crystallization is important. Crystallization is important. For this, weathering, transportation, sedimentation, compaction, cementation is important. Do you all agree with this, guys? For metamorphic rock, you need heat or pressure. Done, guys? Not required, guys. These are not required. This is fine, guys. If they ask you, this is fine. Don't make things complicated, guys. Keep it simple. Yes, yes, yes. Done with this, everyone? Guys, in geomorphology, three basic topics which are connected to geomorphology are earthquakes, volcanoes, and interior of the earth. Okay. So now, first let us talk about earthquakes. Tomorrow we'll finish off these parts and discuss about India's physiography, soils, and all this, as I told you. Okay. So earthquakes. No, ma'am. I just said by mistake. Monday. Earthquakes. Okay. See, guys. Take this bottle. Okay. Convergent boundary. Convergent boundary. I keep pressing it. Can I say after a point the bottle will blast? After a point the bottle will blast. Yes. That releases energy. Okay. The bottle will blast and it releases energy. Okay. Second, we also have, let me say, I'll press it for a while, guys, and suddenly I will remove. Okay, I'll press it for a while and suddenly I'll remove, like divergent boundary. Okay, I was pressing, suddenly I removed. Now, when I remove, can I say the bottle will come back to its original position. Have you seen, like, some sound, right? Yes. So sudden release of energy inside the earth is basically our earthquake. Okay, so what is an earthquake? It is sudden release of energy from inside the earth. From inside the earth. So what do we see? Let us say I have some plate boundary like this. Okay. Now, let me assume at this place some energy is released. This point is called as focus. Focus, or it is called as hypocenter. Okay, guys? It is called as focus or hypocenter. Okay. Now everyone think and tell me. Now I'm talking to you. Can I say sound is coming to you in the form of waves, guys? Can I say sound is coming to you in the form of waves? That is sound energy. Yes. You tell me, I'm standing here and I'm talking. Okay. Can I say circularly everyone around me can listen? Circularly everyone around me can listen? That means, can I say energy normally transfers in the form of circles, guys? So, see, ma'am, energy never goes only in one direction. You tell me, when someone turns back and talk to you, let me say I'm talking this side, you're standing behind me. Won't you listen to me? Can't you hear me? Lakshmi, can't you hear me? You can. That means energy is not only going straight, energy will go in a circular manner. You see, guys, the point where the energy touches the earth first, can I say they will have impact first? Can I say the point which touches first will have impact first? That is called as epicenter. That is called as epicenter. Okay. The point on the earth's surface where energy is first received is called as epicenter. Okay, everyone? I have two terminologies here: focus or hypocenter. Focus or hypocenter. What is this focus or hypocenter? We are going to see here the place inside the earth where energy was released. The place inside the earth where energy was released. is called as focus or hypocenter. Epicenter. No, Lakshmi. There will be only one point of epicenter because perpendicularly energy can reach only at one place. Okay. The point on the Earth's surface, where energy reaches first. Okay. Guys, you tell me, if you are closer to me when I'm talking, if you are closer to me, will you hear loudly? Or if you are far, you will hear loudly? Closer, common sense, closer. Now, the point is, based on the location of the focus, earthquakes are divided into two, guys. Okay, based on the location of the focus, earthquakes are divided into two. One is your shallow focused earthquakes, another one is deep focused earthquakes. Guys, one is closer to the earth, shallow focused earthquakes. Another one is deep focused earthquakes. Can you tell me which one will have more impact on the epicenter? This is one epicenter, epicenter A. This is another epicenter, epicenter B. Everyone will feel deep. No, shallow. Ankita, think until now. Deep means far from the surface. Shallow means closer to the surface. Which one will reach faster, Ankita? Yes, shallow will have more impact. Good. Everyone, you see? On the basis of position of focus, earthquakes are divided into earthquakes are divided into shallow focused, deep focused. Okay, shallow focused earthquakes, everyone, shallow focused earthquakes are mostly seen in divergent boundaries. Now you understand divergent boundaries, guys? Do you remember, do you recollect divergent boundaries? Plate tectonics, divergent boundaries. Yes. Do you recollect convergent boundaries, guys? Deep focused is mostly associated with convergent boundaries. Yes. Do you understand why plate tectonics is first important? Then we need to do these type of things. Shallow focused, more impact. See, guys, this is the reason I keep telling you geography is very easy only if you have the flow. You should know the flow. What should we read one after the other? No, Srirang. Convergent boundary near trenches it will touch, right? trenches will be formed, do you recollect? Near trenches, when it touch, they are deep focused. Done with this, guys, everyone? Are you drawing diagrams along with me? Are these diagrams comfortable? Yes. Then you tell me now causes for earthquakes. Why do you have earthquakes? Causes for earthquakes. First one, I would say tectonic movement, guys. Everyone, tectonic movement. Yes. Guys, tectonic movement. Can we say convergent boundaries? Will it have earthquakes? Convergent boundaries, will it have earthquakes? Divergent boundaries, will it have earthquakes? Divergent boundaries, will it have earthquakes? Transform boundary, will it have earthquakes, guys? Transform boundaries, will it have earthquakes? Yes. Second, everyone, you think and tell, when there is a violent volcano, is there possibility of earthquake? When there is a violent volcano, is there a possibility of earthquake? Yes. You tell me, guys, all of a sudden, big rocks from the mountains fell on the ground. Okay. All of a sudden, big rocks from above fell on the ground. Will it shake the earth? Will it release energy? Will it shake the earth? Yes. That is called as landslides, guys. Landslides. Guys, earthquakes leads to landslides. Landslides lead to earthquakes. You tell me, guys, suddenly, one part of the land, if it goes down, okay, suddenly one part of the land, if it goes down, let us say this roof is there, if it falls down all of a sudden, will there be possibility of earthquakes? Yes. We say subsidence leads to earthquakes. Guys, you tell me, if a very big meteor comes and hits, will it lead to meteoroid impact? Will it lead to earthquakes? Yes. Then guys, you see, mining, guys, okay, mining. Everyone, look at this. I have a piece of land. Minerals are there here, guys. Now what I'll do, I'll dig deeper. I'll go inside. I will loosen this soil. Okay. I will loosen this soil. You tell me, if the soil is loosened, is there possibility of the above layer falling down? Possibility of above layer falling down? That leads to earthquakes, guys. That leads to earthquakes. Okay. Next, removal of underground water. Removal of underground water. See guys, you will have a rock like this, guys, aqueous rocks like this. In this, water will be filled, guys. Okay. Now this is the rock surface. Now let us assume in this region complete water is removed, guys. Okay. Complete water is removed. If water is removed, can we say this becomes empty? This region becomes empty? And then if pressure is exerted on this, yes, will this subside? Subsidence means will it go down? Will this part goes down? See Anjali, normally underground water is present in some rocks. These rocks are called as aqueous rocks. Okay. Now what happens if this water is removed? Okay, completely the water is removed. If water is removed completely, will there be some gap created? Will there be some gap created? Due to this, let us say some tankers will move here. Will they put pressure? Will they put pressure? Will it lead to subsidence? Will the land go down slowly? Yes. See guys, in a place called Latur in Maharashtra, underground water was removed for sugarcane cultivation and it led to earthquakes. Latur earthquake occurred because of removal of underground water. Excessive removal of underground water led to problem in Maharashtra. Yes. Eighth, can we say dams will also add, guys? Dams will also lead to this, guys. Can I say dam means, you see guys, what is a dam? Let us say I have a surface, water was flowing. Now construction of dam basically means, can we say we are increasing the water level? If we increase the water level, will there be more pressure? Will there be more pressure? And if there is more pressure, then can I say it may lead to earthquake? Example, Koina Dam in Maharashtra, guys. Koina Dam in Maharashtra had Koina earthquake because of this. You tell me, underground bomb testing, can it lead to earthquakes, guys? No, Sony, no, Sony. Lakshmi, whenever dam is constructed, ma'am, water is stored. Okay, when more water is stored, pressure will be there from above. When pressure is imposed from above, what is going to happen? If you have soft rocks, they break. Okay, they break. So that leads to release of energy. It occurred near Maharashtra in a place called Koina. Everyone, you wrote this causes for earthquake. Now everyone see here. The instrument that is used to study earthquake is basically called a seismograph. Okay, so you will have seismograph. Now, can you all see this image, guys? Is the image visible to you? Can you see a white paper rolling here? Can you see a white paper rolling here? Can you see this, guys? This is ink, guys. Ink. Okay. Now everyone see here. See here. I have a paper rolled in this form. Okay. I have paper rolled in this form. Now I have a pen like this. You tell me when the pen will be drawing the line per second, it will be going slowly. Suddenly, if there is earthquake, can I say the pen will shake? Suddenly, if there is earthquake, can I say the pen will shake? Yes or no? Whenever the pen shakes, can we say earthquake has occurred? Earthquake has occurred. Can you see these lines, guys? Yes. Now, guys, what happened? People normally kept seismograms everywhere in the world, guys. Okay, they kept them everywhere in the world, and they were focusing on this properly. At this point of time, what they understood was, whenever earthquake occurs, they used to get a shake like this. Again, when earthquake, like, it used to be like this, guys. Anywhere in the world, if earthquake occurs, first small, second small, and then a bigger one. This was mandatory. Now they did not understand why this is coming. Then they thought maybe there are different waves. Energy comes in the form of waves. There are different waves coming from the earthquake. Okay, coming from the earthquake. Now they saw that the first wave which comes is called as P waves. P waves basically means primary waves. The first waves which appear on the seismograph is called as P waves. And the second waves which appear on the seismograph was called as S waves. Okay, see guys, there were two waves initially coming. So the first wave was called as P wave, second wave was called as S wave. Okay. So now what happened, you see, let us say this is the focus. Okay, this is the focus. A, B, C, B, C. Okay. Can you tell me, for focus, which is the epicenter, guys? Which is the epicenter? A. Okay. At A, what they saw? At A, what they saw, like this, like this, like this. Okay. At B, what they saw, like this, like this, like this. At sea, what they saw, like this, like this, like this. Can you see the first two? Are they same, guys? The first two, are they same in all the three? Yes. But can I say the other one, is it reducing as I move away from the epicenter? As I move away from the epicenter? Yes. So what they told, the first two are traveling inside the earth. Do you all agree with me? Are they traveling inside the earth? How are they traveling? You see, one is going like this, another 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 one is going like this. Okay, the first two are traveling inside the earth. Okay, but the last one is going outside the earth. Do you agree, guys? The third one is going outside the earth. So they called these waves as surface waves. Don't worry about all these things, guys. These are technical. Outside means surface, ma'am, near the surface. Okay, these are all technical, not required. What is required for me is earthquake waves, guys. Okay, what is required for me? See here, earthquake means normally waves will come. Everyone, do you agree with this at least? Everyone, do you agree with this? Earthquakes means waves will come. And these waves are called as seismic waves. These waves are called as seismic waves. And these waves are basically divided into, one is called as body waves, another one is called as surface waves. Body waves and surface waves. The one which travels inside the earth is called as body waves. The one which travels outside is called as surface waves. Body waves are called as P waves and S waves, whereas surface waves are basically called as Rayleigh waves and love waves. These are called as R waves. These are called as L waves. These are called as primary waves. These are called as secondary waves. Guys, I will explain this in detail tomorrow. Okay? Tomorrow we'll see this volcanoes, interior of the earth. We will also start with, okay, not tomorrow, Monday. Okay. Yeah. Thank you, sir. Hope you people understood today's class. Okay. Please revise them. Monday, next week, we'll try to complete oceanography. Okay. Next class, next week, we'll try to complete oceanography. We will also complete, geomorphology, oceanography, and India will start this. Tomorrow, that is next class, I will be completing this and I'll start with Indian physiography as well. Indian physiography, Indian soils. And then I'll talk about other things. Lakshmi, class will be there, ma'am. Don't worry.